Dear students, in last class I have explained motion of a body under the action of gravity. Whenever a body falls freely, the nature of motion of the body is a uniform acceleration, and that acceleration is called acceleration due to gravity. It is denoted by small letter g, and which has an average value of 9.8 meter per second square. So, during free fall we can always take initial velocity 0. The displacement is equal to the height from which the body is dropped. The acceleration is positive plus g because the velocity continuously increases, and the time taken by the body to reach the ground is called as a time of descent. When the body is thrown vertically upward, final velocity is 0. Initial velocity is not 0, correct? When it reaches the maximum height, the final velocity is 0. The displacement is same as the maximum height reached by the body. Acceleration is negative because the velocity continuously decreases. So, whenever the velocity decreases, acceleration is negative, and we call that acceleration as a retardation or deceleration. So, that is why A is always minus g. And the time taken to reach that maximum height is called time of ascent. The body is ascending, and we can prove that the time of ascent and time of descent both are equal. So, let us solve a numerical now based on this concept. So, a stone dropped from the top of a building reaches the ground in 2 seconds. So, when the stone is dropped, initial velocity is always equal to 0. We can always write straight away, because we know that when the body falls freely, its initial velocity is 0. It is given that the time taken is equal to 2 seconds, and during downward motion the acceleration is nothing but plus g, and the value of g is given 10 meter per second square. And we have to find the height of the building. The height of the building is same as that of the displacement. So, basically we have to find h, that is nothing but s. So, which is the equation that relates displacement in a given time? That is s is equal to ut plus half a t square. S is nothing but h, the value of u is 0 plus half, the value of a is given 10, and the time taken is given 2, square of it becomes a 4, and this 10 to 4, 40 by 2 is a 20 meters. So, therefore, the height of the building is a 20 meter. So, hope the steps are clear. Very easy problem. It is for 2 marks. It is a 2 marks question. Okay. So, let us see some more questions. A player throws a ball upward. So, when it is thrown upward, the initial velocity is 29, throws a ball upward with an initial speed of 29.4 meter per second. First option, what is the direction of acceleration during the upward motion? See, whether the body falls freely or whether it is thrown upward, the direction is always downward towards the center of the earth. So, that is why the answer to this question, what is the direction of acceleration during upward motion? It is downward is the answer, okay, because force acts downward, so acceleration also acts downward. The next option, find its velocity. So, we have to find the velocity at the highest point of its motion. So, when it is thrown upward, what is the final velocity when it reaches the maximum height? It is 0. So, the value of v is a 0, option B. Find its velocity at the highest point of its motion. Next, option C. To what height does the ball rise? So, we have to find the height. We know the initial velocity which is here. We know the final velocity, correct? And it is moving upward, right? So, what is the acceleration? Sign for it. It is a negative. It is a minus 9.8 meter per second square. To what height does the ball rise, and after how long does the ball return to the player's hand? So, there are 2 options are there. First, we will calculate the height. When time is not given, the one and only one equations of motion that we can use is this. V square is equal to u square plus 2s. Final velocity is 0. The initial velocity is a 29.4 square of it minus, I am writing minus because of this, okay, 2 into the value V is nothing but g minus 9.8 into s is nothing but h, that is what we need to calculate. So this is 9.8 into is 19.6 h and bring to the left. So 19.6 h is equal to 29.4 the whole square, or h is equal to 29.4 square by 19.6. So let me find that value. So first square 29.4 and then divide by 19.6. So we'll get that value to be equal to 44.1 meter. We have to even find the time taken. So first we'll calculate the time of ascent, then time of ascent and time of descent are equal, correct? So we can find the total time, because they have asked after how long does the ball return to the player's hand. That means we have to, that's called time of flight, going up and then coming back, okay, is time of flight. So let's first find the time of ascent. I will use the equation V is equal to plus 80. Final velocity is 0, the initial velocity is 29.4 minus 9.8 into t. So 9.8 t is equal to 29.4, or t is equal to 29.4 by 9.8. So 29.4 divided by 9.8. 29.4 divided by 9.8. So, we will give you 3 seconds. But this is time of ascent, correct, going up, ascending. So, we wanted the total time, that is time of ascent plus time of descent, and both are equal. So, that is why it is 3 plus 3, which is 6 seconds. So, therefore, the ball which is thrown upward will be back to the hands of the player after 6 seconds. Okay. So, this type of questions are 5 marks question. They are all important, and coming Sunday there will be a test. So, start revising, go through all the questions, and on Saturday, so there will be an interactive session, and around 10 o'clock I will tell you the exact time, and on Google Meet. Okay, so that's why you have to download the Google Meet app, and I'm going to send the link just 10 to 15 minutes prior to the meeting. Okay, so that will be on Saturday. So where you can clarify your doubts regarding this particular chapter. So we'll interact, and the session will be about 45 minutes to 1 hour session. Okay, right. So let's try some more numerical. So you can again go through important question, 5 marks. It has appeared twice in the examination. So let's solve this particular question. A stone is dropped from the top of a tower 100-meter height. So first I am going to draw a tower here. So this is the tower, this is the ground, and this tower is 100 meter. So that's the height of the tower, 100 meter. A stone is dropped from the top of a tower 100 meter height. It is given that the same instant another stone is thrown vertically upward from the base of the tower with the velocity of 25 meter per second. When and where will the two stones meet? Okay. So there is one statement which is missing. It's given that a stone is dropped. Okay, it's clear, right? A stone is dropped from the top of the tower. So there are two stones are involved now. So one stone is dropped from the top of the tower. Okay, like this. Let me consider A. like this. Okay, it's a dropped. Then at the same instant, another stone is thrown vertically upward from the base of the tower. So another stone here, B I will write, which is thrown vertically upward, and velocity of that is given. Thrown vertically upward from the base of the tower with a velocity of 25 meter per second. When and where will the two stones meet? Now, when and where? When means after what time they will meet, and at what height do they meet. So let me consider like this, that this stone or these two stones, they meet here, somewhere here at a particular point, at point P, at a distance x from the ground. Okay, if this is x from the ground, what is the remaining distance travelled by A? It is 100 minus x. Correct? So I'm going to write a statement. The two stones meet at a height x above the ground after a time t. Clear? Now for stone A, it's a dropped, right? So what is the initial velocity? Initial velocity is 0. What is the acceleration? It's going downward, so it's plus g, which is plus 10 meter per second square. It's given in the question. What is the distance traveled when they meet? The distance travelled by A when they meet is 100 minus x. Okay, and it's going down, right, descending. So after a time t. So we have variables, which is s, u, a, and t. So the equation that I have to use is s is equal to ut plus half at square. The value of s is 100 minus x. 100 minus x. That's equal to 0 plus half a is a 10, t we don't know. So 100 minus x is equal to 5t square. See, we have an equation in which there are two unknowns are there. We don't know x, we don't know the value of t. So we have to write one more equation, only then we can find the unknown values, right? So this is for A, for the stone A. For the stone B, for B, which is thrown upward with an initial velocity given 25 meter per second. What is the distance covered by it as it is thrown upward? When they meet, it covers the distance x. Time of s and t is at t. What is the acceleration? It's going up, right? So minus g, it is minus g, which is minus 10 meter per second square. So again I'll use the same equation, which is s is equal to ut plus half at square. The value of s is x here. U is given, 25t. Minus because of this, a is negative here. So it's half into a into t square. Correct? So let me solve that here. So now we get x is equal to 25t, 10 by 2 minus 5t square, minus 5t square. So we have another equation, equation number 2. Equation number 1 is here, equation number 2 is here. So you add them, 1 plus 2. So when we add on the left hand side here, we have 100 minus x, and on the left hand side here we have x, that is equal to 5t square, 5t square. Here we have plus 25t minus 5t square. So this x will get cancelled. We get 100 is equal to this 5t square will get cancelled, we will get 25t. So therefore the value of t is 100 by 25, which is 4 seconds. That means the two stones they meet after 4 seconds. Now we have to calculate at what height do they meet. So to find that, you can use either equation 1 or equation 2. Okay. So I will use in equation 2, x is equal to 25 into value of t is a 4 minus 5 into the value of t is a 4 square of it, 16. 25 into 4 is 100 minus 16 5s are 80. So 100 minus 80 is a 20 meter. Therefore, the two stones meet at a height of 20 meter after 4 seconds. So this question has appeared twice in the exam with the different data. Values are different, but the numerical is the same. So we'll solve one more problem. The statement, the two trains A and B of length 300 meter each are moving on two parallel tracks with a uniform speed of 54 kilometer per hour in the same direction. So I'm going to draw two trains here. So this is train A, and then there is one more train. Their lengths are given 300 meter. Are the length of it. Each are moving on two parallel tracks with a uniform speed of 54 kilometer per hour. So speed of both is given here like this. They move in the same direction. Their speeds are 54 kilometer per hour. 54 kilometer per hour in the same direction. With the train A ahead of B. So train is ahead, train is front, and the other is back, B. The driver of the train B decides to overtake A. Since B is behind, he wants to overtake this train A and accelerates by 2 meter per second square. So for train B, this is for train B, the initial velocity is 54 kilometer per hour. Okay, and its acceleration is given, which is 2 meter per second square. That is the initial velocity and the acceleration. Okay, the driver of train B decides to overtake A and accelerates by 2 meter per second square. This much is given. If after 25 seconds, so it's given that after a time of 25 seconds, the guard of train B, so the driver of the train B is here, the guard is here. The guard of train B just brushes past the driver of train A. That means this train accelerates, overtakes, and then it comes here, it comes till here. Okay, after overtaking. This is also moving, keep in mind. This is also moving, this is also moving, correct? So that the guard of B, when it reaches the driver of A, and that happens after 25 seconds, okay, driver of A, what was the original gap between them? So we have to find the original gap means this. Let x be the original gap between them. Okay, so this is the data given. So hope you are clear. So let me repeat. There is a train A, there is a train B. Their initial speed is 54 kilometer per hour, 54 kilometer per hour, and now A is ahead than B, but B wants to overtake A, right? But to overtake that, the driver of the train B has to accelerate, and that acceleration is given 2 meter per second square, and it overtakes after 25 seconds. So this is the data given for train B. So now first what I'll calculate, I will calculate, this is for train A, okay, this is for train A. Its speed is given, speed 54 kilometer per hour, which I'll convert into meter per second. That is a 54 into 5 by 18. 18 threes are here, 54. So 3 into 5 will get 15 meter per second. That is the speed. And in a time of 25 seconds, what is the distance traveled by A? That is what I am going to calculate. What is the distance traveled by A in 25 seconds? Because when the B is overtaking A, the A will not remain at rest, even that also will move, right? That distance also B has to cover, if at all it has to overtake. So what is the distance traveled by A? So speed is equal to distance by the time. So here we are not going to use the equations of motion, because the train A, it moves with uniform speed, it's not accelerating. So that's why we are using the equation speed is equal to distance by time. And now distance is equal to speed into time. The speed of A is 15 into time taken is 25, and this 15 into 25, 25 into 10, 250, and then we have 125, so we'll get 375 meters. So this is the distance traveled by A. And now total distance traveled by B when it overtakes A is, I will write S suffix B, distance travel. What and all distance B has to cover to overtake A? First, it has to cover the gap, that is X. Correct? First it has to overtake this distance. Then it has to overtake the length of A, length of the train A. Then it has to cover its own length, which is the length of B. And then, since A is also traveling, it has to even cover the distance traveled by A. So this is the total distance that B has to cover if at all it has to overtake A. X we need to calculate. The length of train A 300 plus length of B 300. Distance traveled by A is a 375. So therefore the total distance covered by B is nothing but X plus 975. So this is the total distance covered, X plus 970. And now we know the formula for SB, okay, which is U into T plus half AT square. Because now see here we have used the U is equal to SA by T, because B is moving with uniform speed, there is no acceleration. But the train B is accelerating, that's why we have used the equations of motion. So what is SB? X plus 975, X plus 975, that's equal to, what is the initial velocity of B, which is 54 kilometer per hour, and we know that that's equal to 15 meter per second. It's a 15 into 25 plus half. Acceleration of B is a 2 into T is 25 square of it, 25 square. So we have X plus 975 is equal to 15 into 25 is a 375 plus this will get cancelled. 25 square is 625. So the total comes out to be 1000 here, 1000 when you add. So therefore x is equal to 1000 minus 975, which is 25 meter. Now this is the initial gap between the train B and train A. Okay. So hope you will have understood. Again, one more problem, important. These are all 5 marks numericals for the coming exams.